So my project is basically partitioning evapotranspiration into evaporation, transpiration, and measuring the flux of CO2 from the soil and the atmosphere and vice versa. And what's new about this is that we're attaining this set of data using field measurements from actual agricultural fields. And a lot of these measurements right now are sort of models based off of lab data, which, obviously has inaccuracies because it's not in the actual field. And we're using a lot of equipment to measure these, one of which is a sonic anemometer, which measures the instantaneous wind speed, but also partitions it into all the X, Y, and Z directions. And we have the open path analyzer, which is used to measure the CO2 and water vapor levels. We also have a visible and near infrared spectrum camera we just use to measure the amount of plant cover versus soil and plant stress, where it'll take a picture every 15 minutes and just tell us how much green is in that picture or how much brown, basically. And then we have these microlysimeters, which is just a fancy word for PVC pipes we stick in the ground that take up soil samples. And using both the anemometer and the open path analyzer, we're measuring the flux of the CO2 and water vapor, passing through the atmosphere and soil layer. And we use just the vertical wind speed for this, which is on the z-axis, in combination with the levels we measured to quantify this. And the water vapor flux is, we basically affirm this using the soil samples that we take, and we weigh them before and after drying to determine the amount of vapor coming from the soil. And so then the remaining amount is just from transpiration. And we use the amount of soil in the field is determined from the visible spectrum camera, which again just tells us how much green and how much brown is in the field. And the near infrared spectrum of the camera is used to measure the plant stress. So depending on how much water is in those plants, it would reflect more or less heat. More if there's less water in the plants, it's more stressed, and less if there's more water, so it wouldn't be really stressed. And this is our tower right here. Up at the top, we have the visible / near infrared camera. Right here, I don't know if you guys can see my mouse. We have the sonic anemometer, a little 3-pronged thing. It uses ultrasound waves and basically just projects those in between the 3 probes and determines the wind speed based off of how those waves react. And then right under that is the open path analyzer. So we have them as close as possible to just sort of reduce any bias to a minimum. And that's all hooked up to this data logger, the big white box at the bottom. And that's about